Alright, so now we're going to look at additive inverse and just how we can use this additive inverse to rewrite equations. So now that we're dealing with integers that have negative numbers, we can use that and rewrite those to always make a negative or a subtraction problem into a addition. But first we need to know the additive inverse, and the additive inverse is the number that when added to another gives you 0. So it's the opposite number. So additive inverse of 6 is negative 6, because 6 plus a negative 6 would give you 0. Or if you have 6 and you take away 6, you're left with nothing. So real quick, just find the additive inverse of the numbers below. So the opposite of 4 is going to be negative 4. Okay, the opposite of 5 is going to be negative 5. The opposite of, let's just say this is 7.25. So that is going to be negative 7.25. It's the same for whole numbers as well as decimals, and fractions as well as that. And then negative 3, the opposite of a negative 3 is going to be 3. Okay, now the other thing, knowing now that the commutative property of addition states that a plus b equals b plus a, so you can change the order of them. We can apply that to the 8 minus 3. So since that's a minus 3, we have to leave it that way, because 8 minus 3 is 5, 3 minus 8 is negative 5. But if we rewrite this as 8 plus a negative 3, now if we want to switch this, a negative 3 plus 8 is still positive 5. And an 8 plus a negative 3 is 5. Okay, so likewise 7.25 minus 2.5. So when we do that, 7.25 minus 2.5, we get a positive answer. If we were to switch that and do 2.5 minus 7.25, we would get a negative answer. So we can rewrite this as 7.25 plus a negative 2.5. And if you notice, I'm using parentheses. That's just to kind of note that that is a negative 2.5. You're adding a negative number. Okay, so now 7.25 plus 2.5 would be 4.75. Okay, and last, so 4.3 minus 6.1. So we can rewrite this as 4.3 plus a negative 6.1. So now if you were to do this, setting up the standard way, and you said 4.3 minus 6.1, well, 3 minus 1 is 2. 4 minus 6, well, you can't do that, and there's nothing to borrow from. So people would most likely say, well, I'll just add, that's a negative 2, and your answer would be negative 2.2. But that is not correct. So if you put it the other way, so now that we have a negative 6.1, 4.3 plus a negative 6.1, we can rewrite this as negative 6.1 plus 4.3. And now we can treat this similar to a subtraction problem, but now the 6.1 becomes this, and we're minusing 4.3. And then our answer here will just be negative. So now if we do this, well, you can't do 1 minus 3. You have to borrow from the 6. This becomes 5. We now have an 11. 11 minus 3, that's going to give us 8. And then 5 minus 4 is going to give us a 1.8. And now we bring down this negative. And so actually 4.3 minus 6.1 would be negative 1.8. But now by using the additive inverse, we can rewrite this. Using the commutative property, we can switch it to negative 6.1 plus 4.3 and then go through and solve it that way. And so that's where this becomes helpful, especially when we're trying to subtract a larger number that is going to give us a negative result. Okay, next thing, so absolute value. Absolute value here, this is just the distance from one point, or the distance one point is from another. And this is always positive. So absolute value is always positive. So the distance is always going to be a positive value. The direction determines if it's positive or negative. So when we're just looking for the absolute value or the distance, we're always looking for a positive amount. Okay, so how this looks, so we want to find the distance from 10 to 15. So the way we can find distance from those 2 points is we can just take 15 minus 10. And so 15 minus 10 is going to give us 5. So the distance between these two is the difference between the two numbers. Okay, and the best way to always find this is just take the larger number minus the smaller number. Okay, so likewise, okay, so this point right here is on 3.5, and so each of these tick marks represents a quarter, or 0.25. So if this is 5, that'd be 5.25. This would be 5.5, and then where the red mark is, that's going to be on 5.75. So now to find the difference, or the distance, we take the difference of 5.75 and 3.5. And when you solve that, you'll find that, well, that is 2.25. So that is the difference. And it's always going to be 2.5. So even if we did this again, but this time we wanted to go 10 minus 15. So now distance is always going to be the absolute value, or the difference, the absolute value of the difference. So 10 minus 15 is going to give us a negative 15, or a negative 5. But the absolute value, in the absolute value, you use these straight lines to note that you're looking for the absolute value, is actually going to equal just 5. Likewise, the same thing, if we wanted to go, well, what is it from 5.75 to 3.5? And we did, well, that's 3.5 minus 5.75. We would take the absolute value of that. So that might be a negative 2.25, but the absolute value, once again noted by the straight lines surrounding the number, would tell us that that distance is 2.25. So that's just this last part. Just want to note that to find the distance between 2 points, you're just going to take the difference between those 2 points.